I'm sure you've heard the news. The future is here, and it's electrifying. On this channel we dive deep into the world of electronics repair and reviews, making tech accessible and exciting for everyone. Whether you're a seasoned pro or just starting out, we've got something for you. From fixing your broken gadgets to reviewing the latest tech, we cover it all with a beginner-friendly approach. Imagine fixing that old smartphone yourself, or knowing which gadget is worth your hard-earned money. Join our growing community of tech lovers where learning and fun go hand in hand. With easy-to-follow tutorials, in-depth reviews, and a splash of humor, you'll be empowered to tackle electronics like a pro. So, hit that subscribe button and turn on notifications, because you won't want to miss our upcoming videos. Let's explore, repair, and reimagine the world of electronics together. Welcome to Electrotechnics, your go-to for electronics. Join our growing community of tech lovers where learning and fun go hand in hand.
Alright, let's cut through the noise. Today I'm breaking down variable frequency drives, or VFDs, in 3 minutes flat. Whether you're an engineering student or just VFD curious, hang tight. You'll want this in your mental toolbox. So what is a variable frequency drive? Think of it as a smart controller for electric motors. In most factories, you'll find tons of motors cranking away. Pumps, fans, conveyors, you name it. But here's the deal. Most motors only have 2 speeds, on or off. Not super helpful if you want precision or energy savings. That's where VFDs come in. A variable frequency drive lets you change the speed of an AC motor by controlling the frequency and voltage of the electricity powering it. Imagine your laptop charger, but for a massive industrial motor, except instead of just charging, it lets you dial in exactly how fast that motor spins. Let me walk you through how it works. Picture you have a standard AC power supply, let's say 3-phase, 60 Hz, which is pretty typical. That's fixed speed power. A VFD steps in and says, hey, what if I chop this up, smooth it out, and repackage it however I want? Step 1, the VFD takes that incoming AC power and converts it into DC. That's just a fancy way of saying it straightens out the wavy electricity. Step 2, it uses a bunch of electronic switches, usually called IGBTs, but you don't have to remember that, to turn that DC back into AC, but now the VFD can tweak the frequency and voltage. So if you want your motor spinning slower, the VFD sends out a lower frequency, say 30 Hz instead of 60. Want it faster? Crank it up to 70 Hz and watch the motor go. Why does this matter? For one, energy savings. If you only need a fan running at half speed, a VFD does that and cuts your energy bill big time. 2, control. You get smooth starts and stops. No more motors jerking into life and shaking the whole building. 3, safety. You can ramp things down gently to avoid damaging equipment. It's just smarter all around. Now, are there downsides? Sure. VFDs add a bit of complexity, and if you push them too hard or wire them up wrong, you can run into trouble. So, safety first. Always disconnect power before poking around inside any electrical panel. So, next time you walk past a big motor humming along, ask yourself, is there a VFD making that magic happen behind the scenes? If you want smoother machines, cheaper power bills, and more control, VFDs are where it's at. That's it. Variable frequency drives demystified. Catch you next time for another engineering deep dive.